right. For this problem, so we're looking at the stem and leaf plot, right? And on the stem and leaf plot, data's already ordered for you. I got that? So I wanted you to do it by hand. Really and truthfully, what I wanted you to do is do it by hand and check it on the calculator. I got that? So when you do it by hand, remember that you're looking at the 5-number summary. 5-number summary consists of the smallest value right here, the minimum, right? So your min is equal to, thank you, we can also find the largest value from the 5-number summary, which is the max, right? So your max is 151, right, when you read this graph? You okay with that? Now, you need to go and find the medians Q1 and Q3, right? We said the median is where? Where's the median at? The middle of the data, right? So we go, how many data points do we have? 21. So we need to find which one. Then 21 divided by 2 is 10.5. Right, so we need to round up to 11. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did y'all get that as the median? 121. So the median is equal to 121, right? How do we find, now we need to find Q1 and Q3, right? Q1 is the median up here. Everybody understand that? So when you calculate this, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 10 numbers sitting up here, right? So we need to find 5 and 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6 sit here, right? So we need to do what to find the median? I mean Q1. That'll be not 90, minus, but 92 plus 99 divided by what? 2. And I get 92 plus 99 divided by 2. Yeah, I get 95.5. That's Q1. Q3 is going to be the median of the lower half, so we need to count how many again? 1, 2, 3, 4, 5, and 6. So I get this and this number. Take the average of those. So that'll be 129 plus 138 divided by 2. Thank you. Yeah, 133.5. Now, again, I want you to do it by hand because I want you to understand what you're finding when you're finding the quartiles. You're just finding medians, right? Medians of the lower half, which is here, and the upper half up here, right? Your calculator does it for you. So in it, anything more? Stat, calc, one variable. I already have the numbers typed in my list. And if you look here, these should verify our min is 61. Our Q1 is at 95.5. The median is at 121. The Q3 is at 133.5, and the max is at 151. So y'all okay with that? Did y'all all look at y'all calculators?
No.
Why not?
I didn't know you could go down.
What? I never taught y'all that?
I didn't think we were supposed to use our calculator.
Really? I never showed y'all to go down?
No.
I never showed y'all these numbers in the calculator?
No.
Oh man, that's embarrassing. My fault. Now you know, right? There's a reason I didn't show you that. I never showed you that because I wanted y'all to learn how to do it by hand. That's what it was. My fault. Alright, so the next part, sketch a box plot for the data. Are there any outliers in the data? Any outliers in the data? Justify your outliers response by providing the lower and upper fence values on the graph. So we need to create the lower and upper fences, right? How do we create the lower fence? What do we do? Thank you. Find the IQR first. We need the IQR, right? How do you find the IQR? Thank you. So the IQR was equal to Q3 minus Q1, which in this case would be 133.5 minus 95.5. So that's equal to 0.5 minus 90. Yeah, that's 38. So the IQR is 38, right? Now, what does that IQR of 38 mean? What does that IQR of 38 mean? Somebody tell me. That's the middle 50%. That's the middle 50%. And what are we talking about here? Talking about heart rates, right? So the middle 50% of people have heart rates that are within 38 beats per minute of each other. All right? So now to find the lower fence, The lower fence of this data is going to be, remember, the lower outlier is equal to Q1 minus 1.5 times the IQR, right? We know Q1 is what here? 95.5. So we know this is 95.5 minus 1.5 times 38, right? So plug that into a calculator. We do 95. I get this number right here is 57. When you multiply that, that's 57. I do 90. So 95.5 minus 57 is equal to 38.5. That means, what does this mean? That's 38.5. That means anything lower than 38.5 is going to be considered an outlier, right? Do we have any values that are lower than 38.5 in our data set? No. So do we have any low outliers? How do you find the upper outliers? Well, the upper fence is, so the upper fence is Q3 plus 1.5 times the IQR, right? So this time we're going to do Q3, which was 133.5 plus 1.5 times 38 again, right? So that's, this again is 50, this right here is just 57. So that's 57 plus 133.5. I got 190.5. Are there any values that are greater than 190.5 in our data set? No. So do we have any outliers? All right, good. So we understand there's no outliers there, right? Now to graph this, we know that the lower whisker sits at where? 61, right? So we'll put a lower whisker here at 61. That probably should be closer to 60 than that, but that's fine enough. The upper box, the first quartile occurs at 95.5, right? Which is about here. The median occurs at 121. The Q3 occurs at 133.5. So that means the box is made from here to here, right? And then the upper whisker extends to 151. So you get a box plot that looks something like this. So when I look at this box plot, if I ask you to describe it, listen up. If I ask you to describe it, what would you say about this box plot? Why is it left skewed? Has a long left tail, right? So this is a left skew distribution. This is left skewed because the tail here is what? You have a longer left tail. Does everybody understand that? So if it's left skewed, let's go down here. Without doing any calculations, is the mean of the data greater than, less than, or approximately equal to the median? Why is it less than? Good. Left skew distribution. The mean is less than the median. The actual mean for this data set is going to be stat calc one variable again. I got 114 point something. Right? Yeah. I got x bar is equal to 114.76, which is less than the actual median, which is what? 121. So that confirms what we already knew. All right.